The universe's self-destruct button, false vacuum decay explained. Exploring the universe's fate, quantum computing and false vacuum decay. The universe's secret self-destruct button, false vacuum decay and the end of everything. NASA shock. Is the Higgs field a cosmic self-destruct button? False vacuum apocalypse explained. The universe's self-destruct button, how false vacuum decay could end everything. The universe's self-destruct button, false vacuum decay explained. Imagine living on a cosmic tightrope, where the slightest wobble could send everything tumbling into oblivion. That's the chilling possibility some of the world's leading physicists are contemplating. Our universe might possess a hidden, self-destruct button, capable of erasing existence as we know it in an instant. It sounds like science fiction, but this terrifying doomsday scenario is rooted in complex physics, a concept scientists refer to as false vacuum decay. Frankly, it's a mind-bending idea that even seasoned science communicators find challenging to fully grasp. Scientists have issued a stark warning: if this cosmic trigger were ever pulled, it could spell the immediate end for all life. Every star, every planet, every galaxy, the entire tapestry of existence would be unraveled in a flash. Life, reality, everything we understand would simply cease to be possible. At its heart, the fundamental idea is that our universe might not currently reside in its most stable possible state. Think of it like a ball resting in a small dip on a much larger, sloping surface. The small dip is a relatively stable spot. You can nudge the ball a bit, and it rolls back. This is what physicists call a false vacuum. The true, most stable state, the bottom of the entire slope, is the true vacuum. The concern is that if any tiny part of the universe were somehow nudged or pushed into this ultimate, true stable state, it could trigger a catastrophic chain reaction. This reaction would manifest as a rapidly expanding bubble, a region of a true vacuum, that would annihilate everything it encounters as it grows. Professor Ian Moss, a cosmologist based at Newcastle University, offered a helpful analogy to visualize this precarious situation. He described the universe's state as being akin to a tabletop with many dominoes standing on their side. He elaborated, they can stay upright unless some small disturbance topples one, and triggers all of them to fall. Just one domino falling could initiate the collapse of everything. Interestingly, the origins of this potential instability might trace back to the very beginning of time. In the chaotic first few seconds following the Big Bang, an immense amount of energy was unleashed, forcing all the fundamental fields that govern particles and forces into specific energy states, known as vacuum states. But here's where it gets particularly concerning, and this is the part most people miss. Researchers strongly suspect that one crucial field, the Higgs field, the pervasive field responsible for giving fundamental particles like electrons and quarks their mass, and which is associated with the famous Higgs boson, might be stuck in a false vacuum state. What does this essentially mean? It implies that the entire universe, permeated by this potentially unstable Higgs field, could be fundamentally rigged to undergo this catastrophic transition at literally any moment. If the Higgs field were ever to transition or be pushed down to its true, most stable vacuum state, the resulting phenomenon, known as a phase shift, similar in concept to how water changes phase from liquid to ice or steam, but on a cosmic scale with immense energy, would unleash an unimaginable amount of energy. The subsequent chain reaction wouldn't be slow or gradual. It would propagate through the universe with terrifying speed and efficiency, perhaps best visualized, as one analogy suggests, like the instantaneous spread of flames from a single match dropped into a vast lake of petrol. A bubble of this true vacuum would inflate and expand outwards in a perfect sphere from the point where the transition began, relentlessly consuming the entire cosmos in its path. At the leading edge of this expanding bubble, the boundary between the unstable, false vacuum we currently inhabit and the expanding, true vacuum, all that released energy would accumulate into an incredibly thin but unimaginably powerful wall. Dr. Louise Hamade, a researcher from the National Institute for Nuclear Physics in Naples, painted a chilling picture of its arrival. She stated, "We would never see the wall coming, because light couldn't reach us before the wall did. This means there would be no warning, no time to react, not even a moment to comprehend what was happening. If this destructive wall were to collide with our solar system," Dr. Hamade explained, "it would possess such an overwhelming concentration of energy that it would instantaneously destroy any star or planet its path. total, immediate annihilation. This theory raises profound questions. Is this just a fascinating but ultimately harmless theoretical curiosity, or are we truly living on the edge of an existential precipice? Could human activity, perhaps incredibly high-energy experiments, ever theoretically play a role in triggering such a transition, even accidentally? This is a point of significant debate and even controversy within the scientific community, though most agree the risk from current experiments is negligible. What do you think about the idea that the universe might have a built-in self-destruct mechanism? Does it fill you with dread, or is it a strangely awe-inspiring thought? Share your perspective in the comments below. Do you agree with the potential implications of this theory, or are you skeptical? Let's discuss this mind-boggling possibility. Exploring the universe's fate, quantum computing and false vacuum decay. Imagine a universe on the brink of a cosmic collapse, where the very fabric of reality could unravel in an instant. Physicists have just taken a giant leap toward understanding one of the most profound mysteries of existence. What happens if our universe suddenly transitions from a false vacuum to a true vacuum? This radical shift, though currently theoretical, could rewrite the rules of physics and erase everything we know about the cosmos. But here's where it gets controversial. While some scientists argue this scenario is impossible, others believe it's a critical question worth exploring. And this is the part most people miss. The tools to study it are now becoming reality. Nearly 50 years ago, a bold hypothesis emerged. Our universe might be trapped in a metastable state, a false vacuum, that appears stable but isn't the lowest energy configuration of the fundamental forces. Over unimaginable timescales, this unstable state could trigger a catastrophic transformation, collapsing the laws of physics and dismantling the structures that sustain life. The challenge? Simulating this process has been nearly impossible until now. Enter a groundbreaking experiment led by researchers from the University of Leeds, Forschungszentrum Jülich, and the Institute of Science and Technology Austria, ISTA. Using a 5,564-qubit quantum annealer, they've created a rare glimpse into the mechanics of false vacuum decay. Unlike classical computers, which rely on binary logic, this quantum device mimics the behavior of particles at the atomic level to solve complex optimization problems. By modeling quantum bubbles, tiny regions where the vacuum could transition into a true state, the team observed how these structures interact, much like waves colliding in a vast ocean of space. Dr. Jean-Yves Dessalles of ISTA likened the process to a roller coaster with multiple valleys. If the universe is indeed stuck in a false vacuum, quantum mechanics would allow it to tunnel into the lowest energy state, a true vacuum, triggering a cataclysmic event. The simulation revealed that these bubbles don't act in isolation. Instead, they influence each other in a dynamic dance. Larger bubbles absorb smaller ones, creating a chain reaction that mirrors the early universe's evolution. This insight could help refine theories about how phase transitions shaped the cosmos, even billions of years ago. The research also sheds light on the Kibble-Zurek mechanism, a concept that explains how defects and fluctuations emerge during rapid phase transitions. The team's observations confirmed theoretical predictions about how false vacuum decay proceeds, reinforcing the role of quantum fluctuations in shaping the universe's structure. As Dr. Jaka Vodeb of Jülich noted, quantum annealers offer a unique window into non-equilibrium systems that traditional computers can't replicate. Beyond cosmology, this work has far-reaching implications for quantum computing. The ability to simulate quantum field theories using annealers could revolutionize fields like materials science, cryptography, and artificial intelligence. For instance, the team demonstrated how tabletop experiments with quantum devices could replace massive facilities like the Large Hadron Collider in certain scenarios. It's exciting to have tools that let us test the fundamental processes of the universe, said Professor Zlatko Papik of Leeds. But what exactly is a vacuum in physics? Contrary to popular belief, it's not empty space. It's the lowest energy state of all the fields that govern reality, including the electromagnetic and Higgs fields. A false vacuum is a temporary state that isn't the absolute minimum energy configuration. If it shifts to a true vacuum, it would reset the rules of physics, altering constants like the speed of light and the strength of gravity. Imagine playing chess on a board with a specific set of rules. Changing the rules mid-game would instantly transform every piece on the board. This research, published in Nature Physics, represents a milestone in quantum simulation. While the universe's fate remains uncertain, this experiment brings theoretical physics closer to reality. As Dr. Kedar Pandya of EPSRC noted, curiosity-driven research is what pushes us to explore the unknown. So, here's the question: are we truly safe in our current vacuum? Or is the universe waiting for the perfect moment to rewrite the game? Note: materials provided by the brighter side of news. Content may be edited for style and length. The universe's secret self-destruct button, false vacuum decay, and the end of everything. Imagine a universe that could vanish in the blink of an eye, not with a slow fade, but with a sudden, catastrophic snap. Sounds like science fiction, right? But here's the chilling reality. Scientists have uncovered a cosmic, self-destruct mechanism that could obliterate everything we know. And it's not just a wild theory, it's a possibility rooted in the very fabric of existence. Curious? Let's dive into this mind-bending concept and explore why the universe might be teetering on the edge of annihilation. For years, we've been comfortable with the idea of the universe winding down gradually. Picture theories like the Big Crunch, where everything collapses back into a single point, or the heat death, where the cosmos drifts into a cold, lifeless void over trillions of years. These scenarios feel distant, almost poetic in their slowness. But now, researchers are shining a spotlight on a far more dramatic ending, one that could happen without warning and erase not just life, but the very laws of physics themselves. At the heart of this apocalyptic vision is something called false vacuum decay. Think of it as a hidden trapdoor in the universe's foundation. If this trapdoor swings open, it wouldn't just wipe out Earth or humanity, it would unravel the entire structure of reality, from stars to atoms to the space between them. And this is the part most people miss: this isn't a gradual process. It's instantaneous, unstoppable, and utterly devastating. To grasp this idea, we need to talk about energy states. Everything in nature strives for stability, like water flowing downhill to find the lowest point. But what if the universe isn't at its lowest, most stable point? Scientists suspect we might be stuck in what's called a false vacuum, a state that seems stable but is actually a precarious balancing act, like a pencil standing on its tip. One tiny nudge, and it all comes crashing down. Professor Ian Moss, a cosmologist at Newcastle University, offers a vivid analogy to help beginners wrap their heads around this. He likens the universe to a line of dominoes, each one perfectly upright but vulnerable. All it takes is a slight disturbance to topple one domino, and the rest follow in a chain reaction, he explained in an interview with Mail Online. In the case of the universe, that disturbance could trigger a domino effect on a cosmic scale, wiping out existence as we know it. Why false vacuum decay could erase everything in an instant? To really understand why this scenario is so terrifying, let's break it down with a simple example. Imagine a lump of coal. It's packed with potential energy, making it inherently unstable. When you burn it, that energy is released, and the coal turns into ash, a much more stable, lower energy state. Scientists call this lowest energy state the vacuum state. Now, apply that concept to the entire universe. If our universe is in a false vacuum, it's like that lump of coal, waiting for a spark to set off a cosmic fire. Dr. Louise Hamade, a postdoctoral researcher at the National Institute for Nuclear Physics in Naples, provides another helpful analogy. She compares the universe to a marble sitting in a bowl perched on a stool. The marble looks secure, nestled in the bowl, but it's not truly safe. If you give the marble just the right push, it rolls out of the bowl and falls to the ground, she explains. The ground represents the true vacuum, a lower, more stable energy state. On a cosmic scale, if the universe's energy field gets that push, a bubble of true vacuum would form. This bubble would expand at the speed of light, consuming everything in its path: planets, stars, even the fundamental particles that make up reality. But here's where it gets controversial. Not all scientists agree on how likely this doomsday scenario is. Some argue it's a purely theoretical risk, while others believe it could be tied to real, measurable properties of the universe. Enter the Higgs field, a key player in particle physics that gives particles their mass. According to Dr. Alessandro Zanacini, a scientist at the National Institute of Optics in Italy, fields like the Higgs can be thought of as a water surface. When the surface is flat, it's empty, he says. But when a wave appears, that wave acts like a particle, interacting with other waves. If the Higgs field is stuck in a false vacuum, it's like a calm lake hiding a tsunami. One ripple in the wrong place, and the whole system could collapse into a lower energy state, taking the universe with it. What's truly unsettling is the idea that this could happen at any moment, without warning. The universe, in this view, is a ticking time bomb, and we have no way of knowing when, or if, the timer will run out. But here's a thought-provoking twist. Some researchers suggest that human experiments, like those conducted in particle accelerators, could theoretically trigger this collapse. Most experts dismiss this as highly unlikely, but the mere possibility raises ethical questions. Should we be tampering with forces we don't fully understand, especially if the stakes are this high? Now, let's hear from you. Do you think the risk of false vacuum decay is something humanity should take seriously, or is it just a fascinating thought experiment? And what about the idea of human experiments potentially triggering such an event? Does it make you question the pursuit of scientific discovery, or do you see it as an acceptable risk for the sake of knowledge? Drop your thoughts in the comments below. I'd love to hear where you stand on this cosmic controversy. NASA shock. Is the Higgs field a cosmic self-destruct button? False vacuum apocalypse explained. Brace yourself. Scientists theorize our universe might contain a built-in cosmic self-destruct mechanism tied to the very fabric of reality itself. This startling possibility revolves around the Higgs field and a phenomenon called false vacuum decay, a quantum event that, if triggered, wouldn't just obliterate Earth but could erase the entire universe in an instant. Yes, you read that right. A fundamental field permeating all space might hold the key to ultimate annihilation. But here's where it gets truly mind-bending. This isn't about a physical button, but a precarious state of energy our universe might be trapped in. Experts believe we might not exist within the most stable possible energy configuration. Instead, we could be residing in what's termed a false vacuum, a state that's stable for now, but potentially unstable in the grand cosmic scheme. Professor Ian Moss, a cosmologist at Newcastle University, offers a vivid analogy. Picture a long row of dominoes standing perfectly upright. They seem stable, but the slightest nudge could send the entire line crashing down. Similarly, our universe might be perched in a delicate balance. Understanding this requires grasping the concept of a vacuum state. In physics, the true vacuum represents the absolute lowest possible energy state for a field, like wood reduced completely to ash after burning, reaching its most stable, minimal energy form. Dr. Louise Hamade, a postdoctoral researcher at Italy's National Institute for Nuclear Physics, clarifies the false vacuum state with another analogy. Imagine a marble resting comfortably inside a bowl placed on top of a stool. The marble is stable within the bowl, representing the false vacuum. However, this entire setup is unstable. If the marble somehow gets enough energy, like a push, to escape the bowl, it falls catastrophically to the floor, mirroring the potential collapse from a false vacuum to the true vacuum state. This brings us to the crucial role of the Higgs field. Proposed by physicist Peter Higgs, this invisible quantum field permeates the entire universe. It's fundamentally responsible for giving particles their mass. Particles interacting strongly with the Higgs field, via the Higgs boson, gain significant mass, while those interacting weakly or not at all, like photons, remain nearly massless. Essentially, the Higgs field underpins the mass of everything that exists, making it foundational to the universe's structure. And this is the part most people miss. The stability of the Higgs field itself is what's potentially in question. Dr. Alessandro Zanacini, a scientist at Italy's National Institute of Optics, provides context. Quantum field theory fundamentally describes reality using fields. Think of a vast, calm ocean surface. That flat state represents an empty field. When a wave rises, you can think of that wave as a particle capable of interacting with other waves. The Higgs field is one such fundamental field. The controversial and terrifying hypothesis is this: if the Higgs field is indeed stuck in a false vacuum state, a quantum fluctuation could theoretically trigger its collapse into the true vacuum state. This decay would propagate outwards at the speed of light, rewriting the fundamental laws of physics and erasing everything we know, a true quantum apocalypse. This raises a contentious point. Should the sheer, unimaginable scale of this potential threat paralyze us with existential dread? The crucial silver lining, according to current understanding, is that this event is considered extraordinarily improbable. It's a random, spontaneous quantum event that could, in theory, happen at any moment, but the calculated likelihood is vanishingly small. Experts emphasize it's highly unlikely to occur within the foreseeable future, perhaps not for billions or even trillions of years, if ever. We'll need far more scientific understanding before drawing firm conclusions. So, what's the takeaway? While staying informed about the profound nature of our universe is valuable, the overwhelming probability suggests that worrying about a Higgs field-triggered apocalypse is counterproductive. Human life is inherently fragile and finite on an individual scale. Therefore, the most rational and fulfilling response is to embrace the present. Go outside, breathe deeply, laugh wholeheartedly, and cherish your experiences. Focus on living fully and meaningfully today, rather than fixating on a cosmic catastrophe with infinitesimal odds. Do you agree? Should such distant, theoretical cosmic risks influence how we live our daily lives, or is focusing entirely on the present the only sane approach? Share your thoughts below, ***. The universe's self-destruct button, how false vacuum decay could end everything. Imagine this. The universe might have a hidden, self-destruct button that could obliterate all life in an instant, according to recent scientific warnings. From the Big Crunch to the heat death of the universe, scientists have long speculated about various ways the cosmos could meet its end. But now, physicists have unveiled what could be the most catastrophic scenario of all: false vacuum decay. False vacuum decay is a theoretical concept suggesting that our universe might not be in its most stable state. Instead, it could be in a false vacuum, a condition where the universe is temporarily stable but could collapse into a more stable, true vacuum state at any moment. If this were to happen, a bubble of true vacuum would expand through the universe, destroying everything in its path, including planets, stars, and galaxies. To understand this better, let's break it down. Everything in the universe, from simple objects like a lump of coal to complex entities like stars, seeks to achieve its lowest energy state, known as the vacuum state. However, sometimes objects can get stuck in a false vacuum, a higher energy state that is less stable. This is akin to a marble sitting in a bowl on top of a stool. It appears stable but can easily be knocked off, leading to a dramatic fall. In the context of the universe, the Higgs field, which gives particles their mass, might be in a false vacuum state. If disturbed, it could transition to its true vacuum state, triggering a chain reaction that would spread throughout the universe at the speed of light. Dr. Lewis Hamade, a postdoctoral fellow at the National Institute for Nuclear Physics in Naples, explains this with a simple analogy. Think of a marble in a bowl on top of a stool. The marble can stay there unless it receives a push, causing it to fall to the ground. The implications of false vacuum decay are staggering. If the Higgs field were to shift to its true vacuum state, the resulting energy release would be so intense that it would force neighboring areas of the field to follow suit, creating a domino effect. This bubble of true vacuum would expand outward, destroying everything in its path. Dr. Hamade adds, the kinetic energy of the wall is so high that even though the Higgs particles are very heavy, the wall would move at the speed of light. We would never see it coming. But here's where it gets controversial. Some scientists believe that false vacuum decay might have already started somewhere in the universe. Tiny primordial black holes, formed in the early moments of the Big Bang, could potentially trigger this catastrophic event. These black holes, though incredibly dense, are no larger than a single hydrogen atom but contain the mass of an entire planet. As they evaporate through a process called Hawking radiation, they might provide the necessary energy to initiate false vacuum decay. The idea that the universe could be on the brink of self-destruction is both fascinating and terrifying. However, there are reasons to remain hopeful. For instance, the expansion of the universe might prevent a true vacuum bubble from reaching us, even if it starts far away. Additionally, the presence of dark matter and dark energy could play a role in stabilizing the universe, potentially reversing any bubble expansions as they occur. So, is the world already over? Not necessarily. The fact that we're still here suggests that either false vacuum decay hasn't started or that the conditions required to trigger it are not present. Yet, the possibility remains, and it's a reminder of the delicate balance that maintains our reality. What do you think? Is the universe more fragile than we imagine, or are we safe from such a catastrophic event? Share your thoughts in the comments.